Hi, I'm Swarupa Sail, course instructor for Fluid Mechanics. In this presentation, we will go through Bernoullis equation. According to Bernoullis theorem, in an incompressible ideal fluid, when the flow is steady and continuous, the sum of pressure energy, kinetic energy and potential energy will be constant along a streamline. There are some assumptions being made to derive this Bernoullis equation from Euler's equation of motion. And the assumptions are: fluid is ideal, that means it is inviscid or non-viscous, and also fluid is incompressible, that means the density remains constant. Fluid flow is steady, one-dimensional and uniform. And third assumption is fluid flow is irrotational and forces which are considered are only pressure force, that is Fp, and gravity force, that is Fg. Rest of the forces acting on the fluid are neglected. The Euler's equation of motion can be written as dou p by rho plus v dv plus g into dz is equal to 0. To derive Bernoullis equation, we will integrate this Euler's equation. So, integration of dou p by rho plus integration of v dv plus integration of g dz is equal to 0. So, when we integrate each of the terms, we get p by rho plus v square by 2 plus g into z equal to constant. Here we have divided this equation by g, so we get p by rho g plus v square by 2g plus z equal to constant. The first term, that is p by rho g, is known as pressure head. Second term, that is v square by 2g, is called as kinetic head, and third term, that is z, is known as potential or elevation head. So, sum of all the three should be constant. Datum head can be height z and its unit is meter of water or mercury, that is the liquid under consideration. Pressure head is P by W. So, P by W is nothing but rho into G, that is specific weight is equal to density into acceleration due to gravity. So, we write pressure divided by density into acceleration due to gravity. Unit of pressure is force by area, so it is Newton per square meter, divided by unit of density is kg per cubic meter into unit of acceleration due to gravity is meter per second square. We know that 1 kg meter per second square is 1 Newton. So, replace 1 kg meter per second square by 1 Newton. So, Newton and Newton will get cancelled out. So, we will have meter cube divided by square meter. So, finally we get unit of pressure head as meter of water or mercury, whichever is the liquid under consideration. Next is velocity head, which is v square by 2g. Unit of velocity is meter per second whole square divided by unit of g is meter per second square. So, finally we get unit of velocity head as meter of water or mercury. So, these can be shown in this figure, in which there is a pipe of varying diameter, that is the diameter of the pipe is varying from D1 to D2. Let the bottom line represents datum line or reference line from which the datum head, that is elevation, is measured. So, the distance between the datum line and the center of the pipe at section 1 will be H1. So H1 is nothing but the datum head at section 1. Or also H1 can be known as potential head. And if we measure the pressure at section 1, then pressure head will be P1 divided by rho G. So pressure head is P1 by rho G at section 1. Let V1 be the velocity at section 1. So velocity head at section 1 will be V1 square by 2G. So the total head at section 1, that is H1, must be equal to H2. So that is what the Bernoullis theorem states. The head should remain constant along the length of the pipe. So H1 must be equal to H2. So we will write the terms for H2. H2 is again the summation of pressure head, velocity head and datum head. Datum head or potential head is H2 for section 2, which is the distance between reference line or datum line and the center of the pipe at section 2. P2 is the pressure measured at this section. So pressure head will be P2 divided by rho G. If V2 is the velocity at section 2, then velocity head can be written as V2 square by 2G. Thank you.